I am sure that there's a more fancy and sophisticated way of defining field networks when it comes to industrial automation, but I always look at field networks as a way of improving and increasing the amount of data or signals that you get from your plant or send to output devices. They basically allow you to save on equipment and reduce the points of failures when you have a lot of instruments, sensors, or any other field device that you need connected to the PLC. So in simple terms, here is how it works. Usually you get a PLC layer and instrument layer. In this case, the instrument and output devices are wired directly to the PLC cards. Now, when we have field networks, we still have the PLC layer and instrument layer, and then we create a network of data collection points where instruments or output devices are wired to. And then from the data collection points, or let's say islands, we then transmit the signals to the PLC. It's about reducing the number of wires to the PLC while getting all the information from the plant and more. You will see why. So this means that we can go crazy and creative with our wiring in this instrument layer without compromising the PLC in terms of wiring and cost, but still have the control that we need done by the PLC. Let us use an example to explain this. If you work in a food plant, say a dairy plant processing milk, you'd find that these plants have crazy pipework and they have these areas called valve matrices where they have a grid-like setup of the valve because they want to do crazy cool things like filling one tank with milk, but at the same time cleaning another tank and also pumping milk from another tank to the filling line. Some cool stuff like that. Anyway, the process does not matter. What matters is that we have a lot of valves that need to be controlled and give feedback to the PLC. Now let us look at numbers here. Usually you'd find that each tank will have 3 valves, one for filling the tank, another to take the product from the tank to the filling line, and another to run cleaning detergent into the tank. And this is how the tanks will be arranged. So if the plant has 20 tanks, for example, this means that in our example plant, we'll have 60 valves in total. Keep these numbers at the back of your head, they come back later. Now let us have a look at what each valve has from a control perspective. This is the most common case or the most common configuration of a butterfly valve. The valve will have a command signal. This is coming from the PLC and this will tell the valve to open or close. The valve will then have an open feedback that is sent to the PLC as well as a closed feedback that is sent to the PLC. So then in total, this means that we need 180 wires to be installed and wired to our PLC for our example plant. So you may think that 180 wires is a small number, but 20 tanks is a small number for some plants out there. Secondly, PLCs are usually installed in a room or an MCC which is far away from the valves themselves, and the distance becomes more than 100 meters in most cases. Now running 180 wires over 100 meters is not a joke. Remember that cables in a plant do not run in straight lines. You need to climb up to the ceiling, run it across to the equipment, and then run it down again. And sure, someone can say, yeah, but you can run a multi-core cable. But fault finding a multi-core cable over a distance of more than 100 meters will make you hate your job. Trust me. A second example would be if you work in a plant with a lot of conveyors, like in the mines. You'd find that for one conveyor you need a motor, and the motor needs a run signal in the forward direction, a run signal in the reverse direction, a running feedback for the forward direction and the reverse direction. You'd then need a speed switch. You'd need 4 alignment switches for the conveyor, 4 bearing temperature switches, 2 emergency rope switch, and a choke detection switch. This means that for this example, you'd need 16 input and output wires for one conveyor. So what if you have more than 20 conveyors in your plant? remember that typically each conveyor would need these sensors, even if it is a very short conveyor. Another thing you can say is that to avoid long distances, you can move the PLC closer to the instruments or sensors. But PLC equipment is very fussy when it comes to environmental conditions. I mean, you just have to look at a PLC in the wrong way and it will start giving you errors. Secondly, PLC equipment is expensive, so you will not go and put a PLC rack in an area where there are jet sprays of water or thick charcoal dust. You need equipment that is fit for that environment and will be able to collect data to and from the PLC. So with this being said, the idea is that we create input and output networks or I/O networks below the PLC layer. These networks can be scalable based on the amount of input and output signals that we have. The equipment is cheaper compared to PLC cards, and then we can have 1 or 2 cables running long distances from the field to the PLC. So this is how our setup would look like for our tank and conveyor system. So the islands or connection points can be scaled based on the number of inputs and outputs that we need. You can also have spare I/O channels that you can keep for future use or use if one of the channels that you are using becomes faulty. As you can see in this example, you don't necessarily have to use all the terminals or channels that you have available. Of course, this is just an illustration. These field network islands or connection points have digital input and output cards as well as analog input and output cards like a PLC rack. Of course, with new developments, the configurations and connection has changed, but if you are still learning, it is safe to think digital input and output as well as analog input and output. The new developments are still based on this concept. Now, not only do field networks pass signals to and from the PLC, nowadays they can give you data structures that give you diagnostic information, and this is where different manufacturers compete to make our lives easier. Some technologies are advanced that they can be able to tell the PLC that a certain instrument or sensor has lost power or is giving bad data without you having to go to problem solve in the field. You just immediately get this information from the PLC and then you can set it up also in your SCADA or HMI. I'll explain this in detail in other videos because there's a lot to cover in this topic. This was just an introduction to explain why we need field networks.